Hi friends, welcome to another video on fundamentals of electronic circuits. Before we continue, let us go through these initial important slides. Okay, this is what is required. Of course, spend some uninterrupted time with this video to understand what is being discussed in this video. Let us try to see now what is this video is all about. Okay, we are now asked to find we are asked to comment on this circuit operation. Suppose if you change this voltage Vx from 10 volts to 50 volts. So now we know that if you vary the voltage from 10 to 50, naturally the current will increase. Since each resistor will have a maximum power dissipation, so it cannot handle any amount of current. It will want to handle only some rated current. So let us try to find out what is the overall current that will going to flow. So overall current that will going to flow here is Vx divided by the R total. So R total happens to be 110 ohm. So it is Vx by 110 ohms. Suppose if I say this is Vx and I, if this is 10, okay, let me just find out what is this. If it is 10, it is 10 divided by 110, so it will be 90.9 milliamperes. If it is 50 volt, it will be, suppose if I rate it as 50, then the current would be 454.54 milliamperes. This is the current that is going to flow. So let us see if the value of Vx is 10, it is this much current. If it is 50, it is this much current that will going to flow. So let us try to find out what is the maximum current that resistor 1 can handle. So it is IR on max. It is nothing but under root of wattage of this, which is 250 milliwatt divided by 100 ohm, because it is I square into R is the power. So we know the power as 250 milliwatt. We know the resistance as 100 ohm. We can find what is I, which is nothing but this. So what will be this? It's under root of 250 exponential minus 3 divided by 100. Sorry, 100. Close the parenthesis equals. So it is 50 milliamperes. Next, in case of IR2 max. IR2 max is under root of 500 milli by 10 ohm. So it is now 500 milli by 10 ohm. So let me just delete one of them. It is this. So then the current is 223.6 milliamperes. Okay, fine. Let us see when the input voltage is 10 volt. Suppose if you keep 10 volt here, even if you keep 10 volt, the current that would go to flow is 90.9 milliamperes. When this much amount of current flows through this entire circuit, so then the power dissipation of this 100 ohm resistor is how much? So it will be 100 multiplied by 90.9 exponential minus 3. So it will going to have, so it is now this square, I square into r into 90.9 exponential minus 3. So you're going to have a power dissipation of 0.826 watts. So that is 826 milliwatts. So now even for 10 volt amplitude itself, so this will going to burn out. Okay? The power dissipation is more than the rated one, which is supposed to be 250 milliwatt. Even if you keep it as 10 volt, this will going to dissipate more than the intended dissipation, then this won't work. So when this won't work, since this is a series circuit, so when one element of your entire series network is not working, then the entire circuit will not work. So even for Vx is equal to 10 volt, this circuit will not work because the current that would flow is 90.9 milliamperes, which is more than the rated current of this resistor with a quarter watt. So this circuit will not work for 10 volt. So when it is not working for 10 volt, no question of working at 50 volt at all. 50 volt at all. So this circuit won't work at 10 volt. Then at what voltage it won't work, you can find. So what is this 50? This is 50. So then what is Vx max you can think of? Vx max you can think of is this is 50 millivolt it can dissipate. So it is 50 milli into 100 ohm plus 50 milli into 10 volt. So sorry, 10 ohm. So it will be 50 exponential of minus 3 into 110. So you can apply hardly 5.5 volt. So Vx max that you can apply is 5.5 volts. So then the current would be 50 milliampere, then only this is safe. If you apply more than 5.5, then this will not be working properly because this will have a more dissipation. There is no guarantee that this will going to give 100% ohm exactly. On the same lines, let us find out one more circuit where we are asked to find what is Vx. If what happens, you are asked to comment on what happens to the circuit if the Vx varies from 10 to 50 volt. If this is 1 kilo ohm and quarter watt, and this is 100 ohm and 1 watt. So we are asked to find what is Vx. Again on the same lines, so what is I that is possible? It is Vx by R total. R total is, it is now Vx by of course Vx by R total is 1100 ohms. Suppose if Vx varies from 10 volt to 50 volt. If it is 10 volt, let me write it as Vx. This is I. This is 10. If it is 10, then it is 10 divided by 1100. It would be 9.09 milliamperes. If it is 50, then it is into 5 volts. It is 45.45 milliamperes. Let us find what is the maximum current does this can handle. So IR1 max, the maximum current it can dissipate, or maximum current it can accept without dissipating more than 250 milliwatt is 250 milli divided by 1000, and IR2 max is the root of 1000 milliwatt, 1000 milliwatt divided by 100. So it is now under root of 250 exponential minus 3 divided by 100. So it can accept 15.81 milliamperes, and this can allow. So it is now under root of 1 divided by 100. 1 divided by 100, which is this. So it can handle 100 milliampere. So now, so when Vx is 10 volt, the maximum current or the current that would flow is 9.09 milliampere. So this 9.09 milliampere is certainly less than this as well as this. So it is safe to apply 10 volt as your Vx. If you apply Vx as 10 volt, so the current is 9.09, so none of the resistors will be spoiled. You'll have this proper operation. If you apply 50 volt, if this is applied as 50 volt, then the current that would flow is 45.45 milliampere. If this much amount of current flows through this resistor R1, So what will happen, the dissipation will be more than quarter watt. So then, because the maximum current that is allowed here is only 15.81, if you make this equal to 50 volt, then 45.45 milliampere will tend to flow. So since this is more than 15.81, it's not recommended to apply 50 volt. 50 volt. Then how much maximum you can apply? Vx maximum that you can apply would be R1 into IR1 max plus R2 into same current IR1 max. IR1 max. So this would be 1K into 15.81 milli plus 100 ohm into 15.81 milli. So this would be 15.81, sorry, 15.81 plus 15.81 plus, so I think 1.581. So you can apply anything less than 17.391 volt. So this is Vx max. So I can apply maximum of 17 volts. So if you apply 50 volt, it is this resistor will going to burn, or this resistor will not going to withstand that much amount of current. Whereas this may just withstand because this has got a higher wattage, higher wattage. If you want to still operate at 50 volt, so then the rating of this, power rating of this should be more. There is no problem with this. There is no problem with this. This is how the rating of the resistor matters a lot whenever you are operating with larger voltage. So power dissipation matters in the circuit. That's it. Okay. Hope okay now you're getting the hold on what is power dissipation and how does the wattage of the resistor matters in a circuit.